I'm Anil Kumar. Welcome to my series on sequences and series. We'll take up a sequence which is non-linear in nature. The sequence is given to us. We need to find an equation in the form of a general term, which we'll call as t of n, and then we'll calculate the value of the next term. In this question, the terms given to us are minus 7 over 6, 1 over 4, 1 over 24, minus 5 over 48, 3 by 2, and so on. So we're given 1, 2, 3, 4, 5 terms. We need to find the sixth term. But before finding the sixth term, we also have to find the general term. Now, whenever a question involves fractions, as in this particular case, it becomes extremely difficult to solve such questions. Now, here are a few things to note about this particular sequence, and that is to see that we have two negatives here. Do you see there's two negative signs here? Now, how does it reflect if I want to sketch on a graph? Well, on a graph, the first point is negative. We can say, well, we have a negative point, and then we have something 1 by 4, which is positive, and then we have something 1 by 24, which is much lesser, again a positive value. And then as we move, we have a negative value. And let's say this value is negative here. We are not seeing the magnitude, but just seeing the pattern. And then a positive value. It clearly indicates that we have a function which is kind of like this. Do you see that? So that is cubic in nature. So when we are looking at a cubic function and we are expecting that kind of a result, what could be our approach, right? So this is what we call strategy. So one of the strategies could be to go for finite difference. Finite difference is the difference between the consecutive values, right? So if the first finite difference is constant, it is linear. Second finite difference constant will give us quadratic. But if the third finite difference is constant, then that will lead to cubic equation. Is that clear to you, right? We're just jumping to the cubic equation from the given data. That may not be true. But we have to think some way and start our work. That is very important to understand. Correct. Now, second part of this particular question is that these are all fractions. So, how do we deal with fractions? Well, for fractions, first thing is get rid of the denominator, right? So, what we look forward is a common denominator. So that is to say, we could write all these as an equivalent value to 1 by 48, since 48 is the common denominator, right? It is highest common factor in this particular case, right? So we could actually rewrite this series in a fashion that we can take 1 by 48 common, correct? And then we could write the series as minus. Now, 6 times 8 is 48, so 7 times 8 is 56, right? And 4 goes 12 times, 24 times 1 and 2, 12, so that is plus 12. 24 goes 2 times, so that is 2, and this minus 5, correct? And then 2 is 24 times 3 is 72. Do you see that? So what we are working with now is natural numbers, rather integers. So with integers, it is much, much simpler to find the common difference. You get the thing, right? So we'll actually look into this particular sequence, find the finite difference, and then the equation. So that is going to be our approach to solve this particular question, which is extremely difficult. Okay, so let's begin. I'd like you to pause the video at this stage. You now understand the strategy and solve this particular question. Now let us see how do we find the finite difference. Just as I was saying, I'm rewriting this particular sequence given to us with equivalent sequence. So what I've done here is taken 48 as the common denominator. So multiplied the numerator and denominator in a way that we get a sequence with denominator of 48. So now the numerator is 56, 12, 2 minus 5, 72, as we just saw. We'll analyze these numbers, right? So what I've done here, our numbers, term number 1, term number 2, 3, 4, and 5, which are given to us, we have written them as integers, and then we're finding the first difference. So this is the first difference for us. First difference basically is, what is 12 minus 56? So minus and minus becomes plus, we get 68. 2 minus 12 is minus 10, and 5 minus 2 is this, and then this, like this. We are getting our pattern. Let me rewrite this. So So in this particular line, we got 12 minus 56, then 2 minus 12, 5 minus 2, and 72 minus 5. We got our results as shown here. The first difference is not constant. Clearly, it is not a linear function. Now, let's go for the second difference. Now, the second difference will be, we'll do minus 10 minus 68, that gives us minus 78. Minus 7 minus 10 gives us 3, and 77 minus 7 gives us 84. So again, the second difference is also not constant. So this is what we are now calculating, and this is our third difference, correct? We note that the third difference, 3 minus of minus 78, will give us what? 81. 84 minus 3 is also 81. That is constant. So that means that we have the third difference, which is constant. That means what we thought about was a cubic relation. It is true. Cubic relation as the third difference is constant. Clear? And the constant is 81. Perfect. So we also know what is this third difference? This is 81, right? Now, that clearly means that we are looking into a function which is cubic in nature, and therefore we have a general equation, which is a n cube plus a n square plus cn plus d, right? So these are the term number, right? N, right? So Tn we have to write as 1 over 48, since we took 48 as the common denominator. So the general term Tn can now be written as 1 over 48 times an cube plus bn square plus cn plus d, right? Where we have a cubic function as expected. Correct. Now we need to find the sixth term. Now many of you can actually find the sixth term from this particular table itself. So I'd like you to actually pause the video, look for the value of the sixth term. That is very important. However, in this question we are saying first find the general term and then calculate the sixth term. But anyway, we can at least have an idea about it, correct? So let's do the reverse calculation to find the sixth term, correct? So we have 81. If I want a constant of 81, what should I do? I should have a number here which will give me 81 there. So the number here will be what? It will be 84 plus 81, correct? And when I add them up, 4 plus 1 is 5, 8 and 8 is 16, 165. Now, getting back, if I want 165 here, what number could be here? So we're doing the reverse calculation. Do you see that? So this number should be 165 plus 77, right? So if I add 165 to 77, 7 plus 5 is 12, 2, 1, 7, 7, 14, and 1, 242. The number there, the sixth term, will be what? We can go back and add 72 to 242, correct? 242 plus 72 will give us this term. 2 plus 2 is 4, 7 plus 4 is 11, and 1, 315. 314. So we do get a number which is 314. So we can say from our calculations here, very clear, right? So we do get T6 as equals to 314. Do you see how without even finding the cubic equation, we could actually find the sixth term. You get the idea? So reverse calculation. So it's very important to see the reverse calculation. This strategy is extremely important. It saves time, especially if you are given a multiple choice test paper, then this could work in your favor, right? Anyway, we'll now get into finding the equation. Now, there are many ways of finding the equation. Let me also give you a shortcut here, right? Okay. Many students who have done advanced functions can actually use this strategy. They know the shortcut, right? But for the benefit of others, the shortcut is kind of like this. Now, in this particular equation, the value of a can be directly found from the finite difference 81. It is equals to 81 over 3 factorial since we have the third difference as a constant. 3 factorial means what? 3 factorial means 3 times 2. Do you get the idea? So 81 over 3 times 2 times 1. Factorial notation means multiply product of numbers from 1 to that number, right? So you could actually divide 81 by 3 times 2 and get your result, correct? So in this particular case, since it is odd number, you cannot divide by 2, but in any case, you can divide by 3. So you can say 81 by 6, or you can say dividing by 3 times 2 is 6, 21 is 7, so you say 27 over 2. So this value of a is expected to be 27 over 2 from this shortcut method, right? Since this method is not known to many of my students in grade 11, I will actually go in for a standard way of finding the equation. So we'll actually begin with the cubic equation. So here is how we are going to do the solution, right? So we have the given series which we have written as 1 over 48 times the terms within the bracket minus 56, 12, 2, minus 5, 72, and so on. We now know that the general term will be 1 over 48 times an cube plus bn square plus cn plus d, right? Now, there are four unknowns. Since there are four unknowns, we do have to have four equations, right? So that is first thing. So we need to find four unknowns, right? So that means we need four equations. So to get four equations, I'm going to write the term number 1, 2, 3, 4. So we're going to use these first four terms, right? So that means we'll use first four terms. Perfect. So let's use the first four terms and get our equation. Substituting n equals to 1, what do we get? We get a 1 cube plus b 1 square plus c 1 plus d equals to minus 56. Now writing them in values, we do get a plus b plus c as equal to minus 56. Now substitute n equals to 2. So when you do that, you get the equation 2 cube is 8, 2 square is 4, and 2 is 2. So we get the second equation, which is 8a plus 4b plus 2c plus d equals to 12. And now we'll substitute n equals to 3. When you substitute n equals to 3, we get an equation 3 cube a, 3 square b, 3c plus d equals to 2, right? Since 2 is the third value. Okay, and now we're going to substitute n equals to 4 to get the fourth equation, which is 4 cubed, which is 64a, 4 square, 16b, 4c plus d equals to 2. So these are our first four equations to work with. Now, systematically, we are going to eliminate these unknowns one by one and then find the value. Well, first step first, we'll eliminate from these two and get the value without d, right? So we do equation 2 minus 1, right? So when you do equation 2 minus 1, you get a simplified result where d has been eliminated. Similarly, we'll do the difference between equation 4 and 3. So when you do a difference between equation 4 and 3, you get another equation here. Well, you will also do difference between 3 and 2 to get your third equation without d. So we have three unknowns and three equations to further solve. You can easily see that c can be eliminated very easily by finding the differences now. So we'll again take these equations one by one, and when you do that one by one, we eliminate c. And therefore, we get two different equations, and these equations are in terms of a and b, right? So we do get equations in terms of a and b, which is 12a plus 2b equals to minus 78, and 18a plus 2b equals to 3. So clearly, we got this 12a as 6 minus 5, right? So that is to say, when you do the difference between these two equations, you get that equation. Is that clear to you? So 19 minus 7 is 12, 5 minus 3 is 2, and c gets cancelled. Minus 10 minus 68 is minus 78. So you get the equation 12a plus 2b equals to minus 78, correct? Now, we have to find the difference between equation 6 and 5. So when you do 6 and 5, you got this. Now we'll do the next two equations, which is from 7 and 6, right? So let me just do a correction here. This is separating equation 7 minus equation 6, correct? So when you do 7 minus 6, which is, we are now doing the difference between these two equations. So when you do that, you get that equation. So 37 minus 19 is 18. 7 minus 5 is 2. Minus 7 minus of minus 10 gives you 3, correct? So that is how you get the equation, which is numbered as 9, 18a plus 2b plus 3. Is that clear to you, right? So let me, since I wrote it wrong, let me rewrite this, right? So we have 37 minus 19, and that gives you the coefficient, which is 18. Do you see that? So that is how we get 18. Perfect. And now 7 minus 5 is 2, and C cancel. Do you see that? And minus 7 minus 10 will give us plus 3. So we get our equation number 9. Clearly in equation number 9, we have only two unknowns, a and b. 2b and 2b cancels away if I do the difference between equation 9 and 10. So that is what I've done here. So once I do the difference between these two equations, 2b and 2b cancel away. And we are left with 18 minus 12, which is 6. So 6a equals to 81, right? So 81, do you see that was our common difference also? And we do get a as 81 over 6. Do you see that? So we did get the value of a, which is very important, 81 over 6. Exactly same as we actually anticipated, right? 3 factorial is 6, correct? So that is how we got the value of a. Now think, if you know this strategy, then we have one less unknown to calculate. We know a, right? So we could work with three equations also. Perfect. So now we know the value of a. As you can now clearly see, we can find easily the values of b, c, d using one of these equations, correct? The previous ones. Substituting a as 81 over 6. Since you are using calculator, you might as well use the decimal value, which is 13.5, right? 81 over 6 is 13.5 for the time being, right? So I hope you have understood the whole strategy. So the idea was, taking the first four terms, we got the four equations in unknowns a, b, c, and d. Eliminating these variables one by one, we found the value of a. Now, substituting the value of a, we can easily calculate the values of b, c, d, right? So what I'm doing here is, to calculate the value of b, c, d, I'm selecting some equations, right? We'll now work in the reverse order. Equation number 9, which is 18a plus 2b. If I substitute the value of a here, I could calculate b, right? So, and equation 5, which has a, b, and c in it, I'm substituting values for the known values a and b to find the value of c. And to get the value of d, the best equation to use the simplest one, right, which is our equation number 1 itself, the sum of A, B, C, D is minus 56. Correct? So let's continue with this. You can actually pause the video, find all these unknowns and your equation. So once again, we actually began with this series. 1 over 48 was taken common, and we found the first difference, second difference, and third difference was constant for these terms. And so we decided that this has to be a cubic equation, and we also got the value of A. The value of A was 13.5. We selected the three equations from the previous ones to find the values of the other unknowns. So A is 81 over 6, which is 13.5. Substituting back into our equation number 9, which was 18A plus 2B equals to 3, we can find the value of B. So I've just substituted A as 13.5. So 18 times 13.5 plus 2B is 3. Rearranging, 3 minus 18 into 13.5 gives you the value B, and the value B is calculated as minus 120. Is that clear to you? Correct? So we have here the value of B, which is minus 120. Perfect. Now, to get the value of C, we'll now use the next equation, which is 7A plus 3B plus C. We know both A and B. A being 13.5 and B is minus 120. Substituting the value of A and B, we can now calculate the value of C. So rearrange and calculate the value of C. It comes to 68 minus 7 times 13.5 plus 3 times 120, and that is 333.5. We know A, B, C now, and so we can substitute that and find the value of D from our very first equation. So minus 56 minus the values of A, B, and C gives you the value of D, and it comes out to be minus 283. So that gives us our equation with the numbers shown here. Perfect. Now these decimals, it's just not a good idea to write the equation in that particular fashion. So I'd like you to open the bracket and write them as as fractions, correct? So once you multiply by 1 over 48 all these terms, you get your solution, and the general term can now be written as a cubic equation 9 over 32 n cubed minus 5 over 2 n squared plus 667 over 96n minus 283 over 48. Does that make sense to you? Correct? So that is how we get our equation. Well, some of you may like to verify that this equation really represents the sequence or not, right? And then you need to still calculate the sixth term. Perfect. So let's verify and then calculate. So I hope by this time everything is absolutely clear, right? So what I did was that I plotted these points given to us with our equation. So we do get this equation, right, which is 9 over 32n cubed minus 5 over 2n squared plus 667 over 96n minus 283 over 48. So when you plot it, you do get a cubic equation as shown, and the points are right there on the graph. So it clearly indicates that the equation is perfectly fine. You could also verify by substituting the value for finding T1, substitute 1 in the equation. And when you do that, you do get the first term, which is minus 7 over 6. If I substitute 2 in the given equation, in that case, I get the second term, which is 1 over 4. If I substitute 3, I get the third term, which is 1 over 24. Well, likewise, we expect all the terms to be calculated correctly with the help of the given formula, in this case, the cubic equation. So let us now find what is the sixth term. Well, substitute 6 for n. When you substitute 6 for n, then you have these four terms, combine them, use the calculator, get your answer. So the sixth term for us is 157 over 24, right? So we do get answer, which is 157 over 24, correct? You will notice that earlier, we did get some answer earlier, which was what? Let me just see. Which was 314, right? So let's see, does it match? Is it equals to 314 over 48? Correct? So yes, they are equal. Do you see that? So if I multiply this by 2, right, they are equal in fraction, I do get the same result. So you notice how our strategy of reverse calculation worked to find the sixth term without going through all this process. At times, that could be what you need to know and find, and so that shortcut method is extremely important. However, now I hope you have understood the whole process of how to deal with some series involving fractions is so difficult, right? So feel free to write your comment, share your views. If you really like and subscribe to my videos, that'd be great. You can also send email on the address given here to me for any further questions and suggestions. I hope that helps. You can also check my website for latest videos being um, uploaded on this website, right? These questions are actually coming from our students. So let me thank all the students who are participating very actively on my YouTube channel and posting questions which they are seeking solutions for. These solutions are being provided free for all the students. You are encouraged to also post your questions to my email, which is given here, and I'll post you the solution just as I did this for one of my students. So I hope that helps. Thanks for your time and learn from home. Thank you. Keep safe.